the previous video, I talked about how to set up your Excel spreadsheet to calculate your values. And in this video, we're going to take a second to look at how we're going to plot these values in Logger Pro. To plot these values in Logger Pro, you just want to copy the values. So you can just hit Control C. When these are highlighted, now let's go to Logger Pro, highlight the first one, Control V, and it just pastes that data inside Logger Pro. We also want to do that for the position. So we want to do that for Y, and we can do Control C there and paste it here, Control V. One of the most important things you can do, you can see all the data is way down here in the corner, right? We want the data to take up all the room on the graph, so we can just right click and go to Auto Scale, Auto Scale. All right, so now you can see that that spreads the data out over the entire graph and uses all the available screen real estate here. The next thing we want to do is we want to make sure that we label these values. So I just double clicked up here on X, but this X is not X, this is time, and it has units of seconds. All right. So you can see that that changed it up here in the column name, but it also importantly changed it down here in the graph. Do the same thing for Y. In this case, Y is position, and it has units of meters. All right, so now we have a proper graph. Time is our X variable, Y is our position variable. We want to fit the data. All right, so for a nonlinear curve fit, you go up here to the button, right, hover over it that says curve fit, click on curve fit. And in this case, we want a quadratic curve fit because we know that the position goes like 1/2 AT squared for a constant acceleration. So we click on quadratic function, we say try fit, just to take a quick look, it's looking pretty good. And we say, okay, all right. Then I can drag this box around if I want. And you can see here that I get a pretty reasonable value. Remember that this A coordinate system, right? This is A, so it's 1/2 A, so we have to multiply this by 2 to get gravity. So 2 times 4.9 is 9.82. So 9.82 is pretty close to 9.8, and this is our standard deviation. Always make sure that you click this box that says show standard deviation. That's what we want. We want this plus or minus value. We don't really care about this correlation of the RMS value. You can also come in here and change the appearance. It'll make it a little bit easier to read on your graph, right? If you up this font size a little bit, say okay. So just that easily, you have a nice graph. Then you can print this out if you want and attach it, but I think the easiest thing to do is, again, use our nice shortcut of Alt Print Screen. So hold down Alt, hit the Print Screen button, that copies it to the clipboard, go to your lab report, and just do Control V. That puts the whole thing here in your lab report. Of course, you can clean that figure up a little bit with crop. So I'll just crop out everything I don't need, like so, right? And we can stretch it to fit and center it a little bit. And so we have our nice data all presented there, easy peasy, in our lab report. All right, so remember that you have to explain why that this is 4.9 and not 9.8, okay? If you want to get fancy, you don't need to do this, but I'll show you how to do this in case you do want to get fancy. You can always left click on this and say delete. That'll delete the fit. You can try again. So you can say nonlinear curve fit. And you can define your own function. So you can say define function. And in this case, we know that our position equals our initial position, y0, plus, whoops, define function equals y0 plus our initial velocity v0 times x plus 1/2, 0.5 is 1/2, 1/2 times g times t squared. I'll just call this gravity function. I'll say OK, try fit, say OK. And so you can notice here, and again, I'll go here and I'll change the appearance a little bit so it's easier for you guys to see. 14, right? So now it even labels the values you want, all right? So we have y0 in the error, v0 in the error, and the calculated g value of 9.82 plus or minus 0.058, right? And this is the standard deviation it's calculating, okay? So you can take that, and again, just for practice, I'll print screen, Control V, and it drops it right in your lab report, and spend a little bit of time to crop that guy out, right? You can just adjust these. So it makes your nice plot here. All right. Put a caption under the plot and explain it in the text. All right. For practice, I'll just show you that was one of the plots you needed to make. You also you wanted to plot velocity as a function of time, which is going to be a linear function. So you can get fancy in Logger Pro and make multiple columns and multiple graphs, but it's not that easy. I find that it's a lot simpler just to open another incident of Logger Pro. So you can just open another window of Logger Pro. That's no problem, right? Your computer can handle that. Of course, you can save this, right, as whatever you want to make sure you have the data and can manipulate it later, and just in case you made any mistakes. But let's make another one just to make sure we understand the concept. So let's go back to our data. Again, we want the X column to be time, highlight it, Control C, click on the first value, Control V. We got those. Go back here, and we want the velocities, highlight those, Control C, Logger Pro, Y values, Control V. Right, and you can see they're all bunched up. Again, right click, auto scale, and you can see we basically have this linear relationship. Okay, we want to make sure once again that we set these values. So this is time with units of seconds, and Y, and I'm just double clicking on there to bring up this window, is velocity. L-O-C-I-T-Y in units of meters per second. Yeah. Done. And you can see how it changed the labels here on the graph. Velocity in meters per second and time. In this case, we would just want to do a linear fit. There's a shortcut to do a linear fit. You can just say linear fit, or you can go to this curve fitting toolbox and choose, right? If I went here, I could just choose this linear fit if I want, right? And say try. So this is the fit, and just say okay. Again, always make sure that, right? Always make sure that you say show uncertainty, right? Because that's the uncertainty, that's the value we want. All right, again, I'm going to change this so it's easier to read for you guys and for the lab report. Something like this, okay? And the beauty of setting your units like this is it automatically tells you what the units are, right? When you do this fit. So the slope of the line is 9.94 plus or minus 0.2 meters per second squared, right? So you already know that this is a gravitational acceleration, and this is well within the accepted value of 9.8, all right? So again, we have our simple graph. Just Alt print screen, go over to your lab report, and Control V, format picture again, crop picture, and crop it to something reasonable, like that. and set your size. And then your lab report, you'll have a caption underneath the figure, and you'll describe what's going on in the text with the error fit and other properties of the plot. That is it. I hope that was helpful, and let me know if you have any difficulties, or your lab instructor or Marie, and we will try to help you out.